Hello, hello. Back again, day 13. We're only 2 days behind. It's fine. Let me turn down King Gizzard here. This King Gizzard album is absolutely public domain. This is the one album that they released like with no restrictions on use, so I get to play it on stream and have a good time. So, 45 beautiful minutes. So, let's get into the problem for the day. As I said, we're on day 13, and that means the problem is called distress signal. You climb the hill and again try contacting the elves. However, you instead receive a signal you weren't expecting, a distress signal. Your handheld device must still not be working properly. The packets from the distress signal got decoded out of order. You'll need to reorder the list of received packets, your puzzle input, to decode the message. Your list consists of pairs of packets. Pairs are separated by a blank line. You need to identify how many pairs of packets are in the right order. Well, okay, so we've got a bunch of example data here. Interesting. So we've got like nested lists. Oh no. Let's see. Packet data consists of lists and integers. Each list starts with open bracket, ends with closed bracket, and contains 0 or more comma-separated values, either integers or other lists. Each packet is always a list and appears on its own line. When comparing two values, the first value is called left and the second value is called right. Then, if both values are integers, the lower integer should come first. If the left integer is lower than the right integer, the inputs are in the right order. If the left integer is higher than the right integer, the inputs are not in the right order. Otherwise, the inputs are the same integer. Continue checking the next part of the input. If both values are lists, compare the first value of each list, then the second value, and so on. If the left list runs out of items first, the inputs are in the right order. If the right list runs out of items first, the inputs are not in the right order. If the lists are the same length, then no comparison makes a decision about the order. Okay, right, so... Okay, if exactly one value is an integer, convert the integer to a list which contains that integer as its only value, then retry the comparison. Ah, this is... oh boy. For example, if comparing 0, 0, 0 and 2, convert the right value to a list containing 2. The result is then found by instead comparing 0, 0, 0 and 2. Using these rules, you can determine which pairs in the example are in the right order. And let me see if I can get this myself. So, same, less than that one, same. So those should be in the right order in that. I think that's how it's supposed to work. This one we would compare, we're running through these two outer lists. The two items are themselves lists, so we're going to compare those. So that'd be 1 versus 1. No decision is made about order yet. So we move on to comparing 2, 3, 4 against 4. Now, because 4 is not a list, but 2, 3, 4 is, that means that we would convert this into a list. And then we would compare 2, 3, 4. Well, we would compare 2 against 4 first. And the rules here specify if the left list runs out of items first, they're in the right order. If the right list runs out of items first, the items are not in the right order. Now here, the right list would run out first because it only has one item, despite 2 being less than 4. Which means these are not in the right order and the whole thing is false. Now, is that correct? Yeah. Compare 2 versus 4, left side is... What? This literally disagrees with their own rules. They just say, left side is smaller, so inputs are in the right order. But the right side ran out of items. I'm so confused. No, this doesn't make sense. What? What? Okay, I don't understand this at all. So what they're saying here is that I don't understand this if the left list runs out of items first. Because so if we compare this example, we say we're going to compare these two things. Both these lists are obviously going to compare the same. That's not really that interesting. These two are the same, this 4 and this 4, this 4 and this 4 are the same. Then the left list runs out of items, which they say puts them in the right order. Whereas over here, the right list runs out of items first. Is this like a tiebreaker for when we end all recursion? This doesn't make sense. It literally just disagrees with their own rules. Because if we compare 9 versus 876. So, because they're both lists, we're going to compare element-wise. Then we convert that to a list. Then we compare 9 versus 8. Now they say right side is smaller, so they're in the wrong order. That much makes sense. But like, It's like you break as soon as you see a single thing that has the desired ordering. I mean, is that accurate? That seems to be the interpretation here. So like over here, you would expect that they're in the wrong order because you'll eventually hit 7 versus 0. And so, and indeed they say that. So, okay, I guess that's the intended read of this. You want to break as soon as you have any judgment one way or the other about one being less than or greater than the other. So if two lists had the same values up till you ran out of one list, then you use that tiebreaker rule, but otherwise you're not going to. That's super weird and I don't like it, but you know what? I'll deal with it. So let's get into dreams and see if we can do this. Let's see, I'll make this scene, but I need to capture the example data a bit here. So start by capturing that, all the example data here. And then capture the I'll get the two things that sort of define the problem for us. I'll drop them in so that we have that at the ready. This is going to take up a lot of the screen today. But so be it. This is what I have to deal with. So, actually, to buy myself a little more screen space, I'm gonna crop these in. There we go. Beautiful, beautiful. So this is the data that I'm working with. This is a weird one, and one that is obviously recursive. And that is just, gosh. Obviously recursion is my favorite thing. I learned how to do it in the day 12 problem. So now I'm a total recursion expert and I can do it, you know, on command flawlessly. Obviously. But even so, this is you know, it may not actually be recursive. There's aspects of this which are obviously intended to be approached recursively, but I don't know that the part 1 framing of this problem requires recursion because of that early break. You're essentially just iterating through two lists and nesting and unnesting, which is stack behavior, and doing these comparisons along the way. And as soon as you reach a judgment about whether one is less than or greater than the other, you're done. So actually, I think that this may not require recursion. I think we may be able to just make two things that essentially walk through like two lists and just track sort of depth and values along the way. I'm gonna grab my iPad so I can sketch out what I'm thinking, and we'll see if that approach can work on paper, and then try to build it in dreams. So back in a sec. The iPad has battery. It's a Christmas miracle. Let's get the old screen share going. Oh gosh. There we go. So, cannot for the life of me fit everything on screen today. That's fine. There, perfect. Perfect use of the Open Broadcaster software. So, basically, if we take a look at some of their examples here, let's just consider it as literally just a stream of tokens here. I'm going to ignore the commas because I think they're irrelevant to the encoding. Oops, it's 11311. And then 11511. So, what I'm thinking here is that I essentially just need two sort of stack walkers that will they'll have sort of a position that they're looking at, and they will sort of move through, and they'll have a depth basically that we can keep track of. So right now they're both depth 0. And the way that this is going to work, they're both going to step forward to a character. Now this open list thing indicates increasing depth. We're stepping into a list. So that would mean that we step our depth to 1 and move on to the next thing. So what that does is now we compare 1 against 1. They're both numbers and they're both equal, so per the problem I think we just move on. Let me confirm the rules on that. Yeah, just keep moving. So no change to anything. Now we step forward again to here and here, same thing. Now we step forward to here, and now these numbers are obviously different. 3 is less than 5. I think that per their example, this means they are ordered, regardless of anything subsequent. That is indeed the exact procedure that is described in the problem. So, this one resolves, I should have been up here. That one resolves as properly ordered. Check. If we step through the next example, let's just work through on paper and make sure that everything works like we think. So we've got the sequence of tokens this time: open, open, 1, close, open, 2, 3, 4, versus open, open, 1, close, and then just 4, close, right? That's what we're looking at for this next example. These are our sort of list pointers, and the depths, I'm going to color these blue. depths of 0. So what this is going to do is, let's see here. You know, so we step forward. Oh, right. So we stepped forward to this first one and increase our depths to 1. We then step forward again to here, at which point we increase our depths to 2. Move again. You know, to skip ahead a little bit, these are the same. Then we get to here. This decreases our depths to 1. Move again. This is where things get dicey. Oh, to totally complete my input, I did forget that bracket over here, but we're not going to get there anyway. So at this point, things get a little weird. One's a list, one's not, which means that we need to actually treat the 4 as a list by increasing depth to 2 along with the upper list. So we've stepped to depth 2 now. Or do we need to do that? I'm going to do an experiment. We're going to keep this depth at 1. We're just going to sort of say it like it is, where if there's a depth mismatch, I can use that as a sort of better indicator of what state we're actually in. So at this point now, because one of these lists has a different depth than the other, we move the deeper one only, stepping forward to here. So then we're comparing 2 against 4. This is my way of getting around the like convert to a list and try again thing, which seems difficult. So we're going to compare 2 against 4. 2 is less than 4, so they are properly ordered. Check. Is that what they prescribe? That is exactly what they prescribe. Okay, another good sign for my idea here. Let's run the next example, 9 versus 876. Get that right? I think so. So depths of 0. Move forward to here, depth steps down to 1, move forward to here, and that's where something interesting will happen. So if we're looking at depths of 1 when we step to here, now this is another situation where this one steps down to 2, but then because they are different depths, we're going to only step the deeper one forward. So now we do 9 versus 8. This is incorrectly ordered, and therefore the whole problem is done. This also agrees with them. I know I'm belaboring this point, but I really don't want to spend a bunch of time implementing the wrong algorithm because it's going to take me probably the next 2 hours minimum to implement whatever algorithm it is that I come up with. So so we got this 4s example now. So we've got open 4 4, close 4 4. And we have open 4 for close for 4. Yeah. So those start at 0, and we're going to speed run the explanation a little bit. Down to 1, down to 2, same, up to 1, same, and here is the only point where something interesting will happen. So at this point, we're at depth 1. And what we're basically going to see here, at this point we can tell if we see mismatched closes. If we see a close, but we don't see 2 closes, then that means the lists were different lengths. So to be clear, what we're seeing here is same mismatched close, same depth. And what this means is that we will terminate right here, no matter what. But whether it's true, whether it's like valid or invalid pair, depends on which list is shorter. In this case, the left list has fewer items, which means per their rules, the left list should be shorter, which means that in this case, check. Right? Did I get that right? Yes. Okay. Now we're getting there little by little. But that's the interesting thing. I think if I were to go back and look at some other situations here, what we have is, in both these cases, we have mismatched open, advance, deepest. That's the sort of key insight from that section. It was basically the same here. That's the main one there. Let's step to the next example now. We've got 7. So open 7. We just got 4 7s versus 3 7s. So that is going to, step forward to, so depth 1, same, mismatch depth again. So we're at depth 1. That does not look like a 1 at all. There we go. In this case, again, it's mismatched close, same depth, but reversed, which means that we say no, this one fails. Is that correct? Yes. Next. Empty list versus 3. This is going to be a good one to stress my understanding of the problem. But I think my algorithm will handle it. Stop doing that. So, depth 1, mismatched depth, or mismatched close, but same depth. Therefore, left list, since left list is shorter, this is valid. Yep. All right, this one's gonna be weird. 3 nested lists versus 2 nested lists. So this one isn't quite accounted for by anything I've laid out so far. So let's see how that pans out for me. Basically, depth 1, depth 2, and now we have a mismatch. I need to decide what to do. Now what this means, I think, whoops. I'm honestly not sure. I think that the implication here is that, well, let me break down what the actual conceptual thing is. We're comparing this versus this at this stage, the inner lists, which means that the right list runs out first, and therefore the whole thing should be invalid, right? But how does that apply to my algorithm up here? If we see this might break my algorithm here, because I'm thinking of some other cases that are really unpleasant. Although I'm only going to implement it for this example set anyway. Although I should probably look at my real input and see if what's a little bit different. I can walk through an example that I think this definitely won't handle. But basically what we're seeing here, by virtue of seeing a close without a corresponding close on the other side, is that the list with the close has run out first, and because it's the right one, we say no good. So to be clear, mismatched close at the same depth yeah. Now I'm obscuring that one. That one's not really gonna... There are other cases that I feel are important to handle here that this is not going over. So let me draw out some cases that I have in mind. I've got 1, 2, 3 versus 1, 2. Or here, let me do this. We're going to do 1, then a list containing 2, then 3, versus 1, 2, 4. You see what I'm going for with this? This should compare against this perfectly, and it should move on to the 3 versus 4 comparison, at which point we should see it's valid. But how would the algorithm handle this? Depth 1, same value, and then we get that mismatched open. So we are currently at depth 1, and what we do in this case is step down to depth 2, just like implied, and step forward. Then we compare these two. Yep. Those are the same, so I'm gonna say that we only step the deeper one again. Now we see mismatched close, different depths, which this is closing the deeper one, which I suppose could only ever happen. That can literally be it's literally impossible for us to close the upper one because we're not advancing the upper one, so that's trivially true. Don't really need to worry about that condition later. But in any case, this steps us back up to depth 1, at which case we can move both. So that handled that situation just fine, actually. Let me break it further. So if we have 1, and then the list 2, 3, 4, and then I just do 1, 2, 5. The prescribed way to compare this is for us to compare these two items. So we're going to compare 2, 3 against converted to a list 2, which is going to result in this list running out of items first, that list running out of items first, which is not allowed, so this whole thing should be invalid. Now, I kind of don't think my algorithm will do this right now. Because here's what I think is gonna happen if I do this naively. Depth 1, same value, mismatched open, which steps this one down to depth 2. And then we step this forward. Same oh no. I gotta delete those or I'll never be able to select anything. Then we step this forward. I've kind of drawn this in a janky way. Also, I somehow erased that. And that's not what we should do. Oh wait, no, I wasn't supposed to move this at all per my own rules. We only would step the deeper one. However, we really, at this point, should have realized that this was not okay. We shouldn't have stepped through to compare 2 versus 3. My own rule has failed me. I could maybe hack around this with like a flag of some kind. That's just like we did our one comparison on this list. Like some sort of flag is merited here. And at that point, because that would be at the end of this step. We've done our comparison on this sort of anonymous list. So that would be, what would I say here? Basically, maybe I would set a flag to be like, this is like a pseudo list or something. And then when we do the comparison, we do actually we did like a PS compared sort of thing, where we did our one comparison for that. And if that happens, then we would only step the deeper one forward as usual. However, if we see an integer in the deeper one, hey Jimmy, if we see an integer in the deeper one, but we've already got this PS compared thing set, then it's no good. That is, I think, how I could robustly handle that situation. So let me jot that down. So this is a weird, very programmery problem. I'll fill in a second when I'm done writing down sort of my results here. Int in one, PS compared in other. Oh, my music. No, King Gizzard. Release more public domain music so I don't have to go back to lo-fi. PS compared in other. Is this like a secret? Well, I can't complain too much. I asked for more music. They give me a bonus track. Anyway, if there's an integer in one and the PS compared flag is set in another, then that is just bad. So mark whole thing bad. That should apply up here too. What we would have done in this situation is we would have basically gone in and said, like, look, we've got, you know, we go into our like pseudo list situation here with 2, then we step forward to here, we do our comparison, that sets PS compared, then we step this forward as usual, but now because we see the close in 1 and PS compared in the other, then we can step back up to 1 and clear the flags, and that works. So, okay. So, now that I've persuaded myself that my algorithm can work, let me briefly hop back to the problem just to kind of restate it. So, they're asking me to take lists, like pairs of values, which are lists containing numbers and lists at kind of arbitrary depth. And I'm supposed to follow a few rules to determine if these lists are in sorted order correctly. So this one you can see it's like 1, 1, 3, 1, 1 versus 1, 1, 5, 1, 1. 3 comes before 5, therefore this one correctly comes first. This one over here gets a little more complicated. You compare these lists against each other and then recursively these numbers against each other, they're the same. You move on to here, then you've got you're sort of just supposed to treat this 4 as a list on its own. So you're comparing the list 2, 3, 4 against the list containing just 4. Then you would compare 2 versus 4 and see that they are in the right order because 2 is less than 4. That's the type of rules that they've got here. I don't want to do recursion because that will make everything dramatically harder. So what I have done instead is I think I have devised a technique that allows me to do it completely iteratively with no recursion, which I'm happy about, because to do otherwise would suck. So I think to try and like sum up, we've sort of got a state machine here. We've basically got like, or I guess if I were to pseudocode the program, hold on, I need music. If we were to pseudocode this program, it would be basically if both numbers then compare, you know, and do whatever if they continue on if they're not both numbers. If let's see, I need to phrase this correctly because of this situation here. Which one takes precedence, a mismatched open or a mismatched close? I'll say a mismatched close. If mismatched close And same depth. Then fail. Because we shouldn't have seen such a thing at all. Well, I guess I'll say resolve, because it's not a failure if the left one is that one. But if they're not the same depth, then I think that the only way that we could see a mismatched close and for them to be different depths is one of these cases above, which is where we would reduce depth on the close and clear flags on other. Or really just all. Clear flags on both sides. If we get a mismatched open, then step depth, increase depth on one, and set PS list pseudo list on other. I guess I need something for if they're both you know what, this part of it could move down basically. And now I know that this is not going to represent perfectly because Dreams isn't procedural anyway, but even so, if they're both numbers, then compare. If both open / close, change depth accordingly. And then finally, after we've done all that, step deepest, or both. And this is where I didn't account for one of these. Let's see. Oh, I don't even need the flag to be set on one list or the other. The depth tells me. That's a nice little simplification. And the catch here, the one remaining thing is if they're both numbers, we actually don't want to just unconditionally compare. We want to say if PS compared, if we did our pseudo list comparison, which can only be a single item, then we will resolve there. Basically, it'll be like one of them ran out of items first. Otherwise, we are going to go ahead with the comparison. Hold on. So we're going to compare, and then if PS list is true, then we're going to set PS compared. Okay, this is a great, super simple, very easy to follow algorithm that I'm very pleased with. We will see how this pans out. I'm pretty sure this is still easier than the recursive solution that sort of naively comes to mind. Easier to implement in dreams. I'm pretty sure it's definitely more difficult to implement in a real programming language where you get recursion for free. But that's not the world we live in. So I will keep referring back to this, I guess. How am I going to get this to myself? Let's see. Because I want to get this on stream here. But because it's on my PC and this is on my iPad and I don't have magic Apple copy, I think I need to send it to myself via Discord. It's my favorite thing. Okay. That was a fun excursion. Let me grab that from my Discord here. Get that on screen. Way too much stuff happening in no. Too much. Not gonna be able to see anything. This is the mess I have found myself in. Well, in order to make my stream slightly less claustrophobic, let's start by encoding all of these lists, and then we can start working through the rest of the problem. Because then I can hide those and free up some screen space. So, let's make ourselves a program. On this microchip that does the stuff is going to be our input. Now, this is going to be a little odd. Basically, what I'm thinking for output is left symbol and right symbol. Because we're going to be sort of stepping through one list at a time. And basically just outputting for each pair that we're currently on. For each pair of lists that we're currently on, what's the symbol that each thing is currently looking at? Our way of stepping through this is going to be a little funky. We're going to need sort of two different, it's going to be like a pair of iterators here, I guess, because what we're going to need is also left done and right done, because weirdly, like, we're not guaranteed one might finish before the other. Now, for each of these, we are also going to have the usual selector dance, where we have, in this case, we have open, 1, 1, 3, 1, 1, close. 7 list entries. The open and close brackets are explicitly being treated as symbols in what I'm doing here. And so now we can go ahead with our usual number slider madness, where this is going to go from -2 up through, I'm going to assume, actually it doesn't matter in my case, up to 9. So 0 through 9 are valid values. -1 will be open, -2 will be closed. Arbitrary, but that's what I am deciding to make it. We line those up. Then what we can do is just encode 1, 1, 3, 1, 1, close. Oh, and this is supposed to be open there. Hook up the power to each of these. I screwed up that one. Put it on visibility instead of power. Can't see. I can't see any better than you can. So these are the values I got coming out here. Each of these then is going to be hooked up to this outgoing node. And I guess, let's see. I guess we don't really need left done. We're gonna have iterators in here that will tell us when we're done. Well, no, we do need to output that. I don't need to hook it up to anything over here. Let me still shuffle these around a little. The one remaining thing I need is left count. Which I'm going to try my luck and hook up to the number of ports. So that makes one list. Let me also, no, not a microchip, a node. Grab the left index. The thing that we are currently selecting on the left side. Now, what's funky is that I need to have many of these pairs to go through, but to be honest, I'm just not even gonna think about that yet. It'll be probably enough to step through just 2 hard-coded lists first. So let's get a bunch more space. Copy all this down. Including this. This is going to be right count. Hook up that thing. And let's encode open 1 1 5 1 1 close. Let's hook up all that. The done ports, I guess I'm still not entirely sure what to do with. To be honest, they're going to be vestigial for a bit. Actually, they're not even going to be here, now that I think about it. So, because we're going to have 2 iterators outside. Let's grab my iterator 2.0 and set up 2 of them. One of these is going to be for stepping through the left string. The other one's going to be stepping through the right. The logic for which ones we step next to and all that are going to be determined on a whole pile of extra logic. So, but because I have my rules, I'm going to immediately set up step left and step right wireless transmitters here so that I get my proper cycle break and frame delay whenever I loop back around to the start of this. So let's just start with that. Create those first so that I can easily grab them by name here. Step left hooks up to next. It listens in the whole scene. Not that it super matters. This will be for step right and do the same. So I now will have the ability to step to whatever the next character in the string is. I think I should add some debug up here just to like visualize each. I'm just trying to make my life a little more sane here. If I get a value slider, which I convert to this, we're going to have left symbol here and right symbol here. Oh, these both need to wrap around like so. Anyway, so now we'll be able to see what we're looking at for each. Now, this is already wrong, which I'm thrilled to announce that we've already somehow made a mistake. The mistake is that neither of these step down to -2, nor do they step up to 9, so they're not going to show us the correct value range. There we go. Problem solved. Hey, Coinem, it's going well. If you're unfamiliar, I'm doing a programming challenge called Advent of Code, but in Dreams. If you're unfamiliar with Dreams, I can give that spiel too, but since you're watching me in the Dreams category on Twitch, maybe you know. So we've got 2 opens here, and so this is really now where we get into kind of the thick of it. So you see I've got this whole thing up here, which I'm regretting writing in blue pencil because it's really hard to read. So I've been on Dreams. I'm relatively inexperienced in Dreams. I mean, I got the game closer to when it came out and did an ambitious project in it. Like, I toyed around with it a lot, really just on the programming side. Like, I am a programmer through and through, for fun and profit. And I was interested primarily in what programming felt like, you know. So everything I make is just kit bashed stuff from the Dreamiverse, trying to do weird programming stuff. And so a yearly programming challenge called Advent of Code is a perfect way to exercise that. I want to see. I'm not happy with like how hard it is to read that one image, so I'm kind of curious if I can like. Can I do like some super contrast on? Ah, I've done it. That's definitely easy to read, right? So I've got, the problem here is asking me to compare these lists that you see on the side here and to report if each pair is ordered correctly. And they have a bunch of rules about what that ordering means. Like, so the top example here, 11311 versus 11511, the top one is sorted before the bottom one because 3 is less than 5, right? 1 is the same, 1 is the same, 3 is less than 5. So that means that that one is ordered correctly. This one down here is also ordered correctly, but for funny reasons, because the lists containing 1 sort out the same, but then you have to sort of treat the lone 4 on the bottom as a list containing 4, and then compare list by list, so then 2 is less than 4, so it's still good. But then this one, you open the 9 has to treat like a list, and then the 9 compares to the 8, and then it's weird. Now, they're clearly, in the design of this problem, angling for a recursive answer. It's extremely clear that that's what they are expecting, because like, if you look at the problem here, if you look at their explanations of what they do, you can see how they sort of like use the same solution at different levels, where you're comparing this list versus this, but then you're going to step in and actually compare this list versus this list, and then you're going to step in and compare this number versus this number, and that gets you your result. Then next you would compare this versus this, like so, and then you're going to compare 2 versus 4. You could write a general, it's all phrased so that you could write like a single function in your program that is like, compare this value versus this value and give me an answer. And then because you're doing it with lists, then it can call, that function can call itself on the list inside of itself, and so on. It would be very easy to do recursively. However, I'm in Dreams, which doesn't really make recursion easy. And the thing about that, is that it's actually, I came up with a way to do it that doesn't involve recursion. And it's a little bit more complicated because, you know, you can see this whole algorithm up here, and I've got this stuff where I like step from one number to the next. But I think that it will be easier to implement in Dreams that way. So despite being a little bit more difficult in my head, it'll be way easier to implement. So loops are difficult to make. I've been fighting that a lot. And that's what this iterator thing is here. It's like a wrapper around a counter that has some extra state related to, actually it really has very little extra state right now. It really just wraps a counter, but also has explicit signals out for like, because I had issues where like, you want to like explicitly step the counter to the next value on one frame, and then use the value on the next, and then step the counter, and then use the value. You don't want to overlap these or you get really confusing issues. So I've got like a wrapper around that that helps me do that stepping. And that's I mean, that's just a small part of the stuff that I have to deal with. Let me save this quick so that I can hop out and show you what some of my other solutions have been looking like. So Advent of Code 2022, day 13, and then I think this is called what? Distress signal? So if we hop out of this then to go into some of my prior solutions, we've got stuff that asked me to move crates around, and I did so by literally moving crates around. This follows a whole complicated sequence, and it's extremely fragile. I learned a lot about how to cause and avoid like same frame, off by 1 frame kinds of issues doing this one. Let's see. I did this. This one was kind of a fun one where like you imagine that there's a rope stretched between these 2 elves, and the front one is like pulling the back one around, and you're supposed to track where the back one goes if the front one follows a particular sequence. Oh. That wasn't, you weren't supposed to be possessible, but like, sure. Let's see what else I got here. And then Monday's was just absolutely bonkers. It does like a recursive flood fill by like having all these elves clone themselves as they go across the grid, such that you guarantee that whichever elf clone makes it all the way up to the top was in fact the whichever one makes it up to the top first, however many steps it takes to get there, you guarantee it took the shortest path, because you flooded the thing and took every possible path up to the top. So 31 is the right answer for that day's problem. So I've been building up a bunch of these techniques, but like the recursion thing was so gnarly that I was like, no, please, I don't want to do that. No, please don't make me do recursion again unless I absolutely have to. And so today I am attempting to avoid recursion by doing this algorithm that turns it into an iterative problem. So it's just a loop. It's not a loop plus a bunch of like emitting of myself. So I hope that it will be a little bit more straightforward. That said, I'm not really sure how I want to like visualize the results here. I'm gonna start, this one's so pure computer that I'm going to, I think, just try to implement it in pure computer form. There's a lot of core logic that has to work regardless of any visualization. So I will start by, let's see, I need variables for left depth and right depth. The way that I'm implementing my solution, I'm going to, whenever I see an open bracket, which is represented by -1, I'm going to say, okay, I'm 1 level deeper. Whenever I see a closed bracket, which is represented by -2, I'm going to say I go 1 level shallower. So I need variables to track this for me. By the way, back when I did my early experiments in Dreams, they didn't have the scope system. I'm pretty sure they didn't have the scope system on wireless transmitters, variable modifiers, that kind of thing. And let me just say, it is such a godsend to have some control over that now, because I was like always so disappointed by the fact that it's like, man, I really just can't use variables for anything complicated because I can only have 1 instance ever, global to the whole program. And you know, anything that I wanted to have like variables per thing is just like, you cannot. That was a real bummer. But I'm very glad to have the whole system now for that. So let's start by working through, I like tried to pseudocode my algorithm here. We first check for mismatched closes and opens. So basically, if one of them is a close and the other one is not, I'm going to create the logic for that, but not necessarily hook up all the, or I'm going to set up the like condition that checks if that is true, but not necessarily the result. Like not actually doing the rest of the program logic. I just want to sort of scaffold all of my logic here before I get into all the specific behavior. So a mismatched close would mean that one of them is -2 and the other one is not. So I'm basically going to need something that just checks if value A is equal to -2. And I think that basically it's going to work like, let's see, I need to call this one left and the other one right. Fascinating, I didn't know you could get to that. So if this one equals -2 and this one does not, oh, I was gonna do if this one equals -2 and this one doesn't, or this one doesn't and this one does. But what I realized I can do to simplify is simply if these are not equal, oh, this is literally XOR. Wow, we're just like continuing to logically simplify here, aren't we? Perfect. That is, at long last, I use an XOR in my program. It's about time. So this one is -2, or this one is -2, but not both. That means that we have a mismatch. That is actually nice and succinct logic. Happy with that. Why is it so hard to grab the right side of these? Oh, whatever. This is going to be called the mismatched close in order to be consistent with my pseudocode. So we've got that. We've also got mismatched open, which is going to be extremely similar logic, but checking for -1 instead of -2. We have to make sure to check these in sequence, and that's the little bit funky thing. And we'll see how that goes for me. So we've got mismatched close, mismatched open, and then if they're both numbers, and then the other case, I guess, is that they must both be open or both be closed. So let's make one that is, they are both numbers. Pull that over again. Get our result handy. And this is really just going to be an AND where I check if they are both greater than or equal to 0. Simple as that. Both numbers. So, I mean, I can see it's not a mismatched close, it's not a mismatched open, they're not both numbers. In fact, I guess now this is, I need to actually check if they are both open or close. Although really, it's just kind of the else case. That's the only possibility remaining. See you, Quentin. Thanks for stopping by. So I need to, unfortunately, sequence these things, but I think that I can sequence them with power, which is a little funky, but it's not so bad. So if this is not the case, then we would power this one. And then if that's not the case, then we would power this one. And then if that's not the case, then we would go do something else. You know, and this is like currently not active, right? So we need one more not down here. And that is going to basically just be, I think we need the like, I'm gonna just make a microchip that is to like take us to the next state here. Or let's do one state at a time. So we have to start with change depth. So we need to know what these both are. I guess technically what only one of them is. So if it's -1, then that's an open, so we decrease the depth, or we increase the depth. Otherwise we would. I'm just gonna set this up in like the extremely obvious way, not try to do any clever math tricks here. If this is -1, then we are going to power on. I'm going to have variable modifiers here for left depth and right depth. But I want to pass the same, well actually it's going to add to it. I'm going to grab a sliderizer again. One of them is going to add 1, the other one is going to subtract 1. Both are going to be visible like this. So this is going to be powered by this guy, and this is going to be powered by, I mean really it's just the other, but I'm going to be super explicit for myself here, -2. And both of these are going to wire into both of these. We're changing the depth, whoops, by the same amount for both. If we see an open, then we increase the depth of both. If we see a close, then we decrease the depth of both. So that should basically do it for that. And what that indicates to me is that that should be powered by this. So when we run this step, well, we have the annoying first tick problem. Let's see, if I were to just, no, it didn't work. Huh. The first tick issue here is that neither of these guys even become active until Well, this is real annoying. I guess what I could probably do, I mean, I hate it, but it's reasonable, is to grab the init delay block that I made a while ago. And just throw it on that, so that now, that still doesn't work. Well, that's just fascinating. And I suppose it's because I didn't hook this up to anything. Okay, so that works. What if that was the issue? Oh, that was the issue. El Stupido. Okay, I wasn't actually wiring that up, so joke's on me. So now, first thing that it does is those variable modifiers activate. They step the depth to 1, at which point we'd be fine to step to the next thing, which I'm going to do with a switch for now. Oh, I guess the output of each of these should probably be whether to step the left or step the right. Because different nodes are going to have different opinions about that. So step left. Step right. Both of these are just going to be switches, like we unconditionally step to the next. Those will just be on. This then wires up to here. Annoyingly, that gives me like a stupid off by 1, like 1 frame issue, which I love. I love that. So what does that mean for me? It means, I suppose, that I need to power these on by this. That did actually work. So when I run this, we're currently on the open pair here. When I power this on, we step to the next thing by virtue of kind of the single pulse of that. Oh man, there's a lot of other stuff that I need to consider here. All of this logic probably needs to share a single microchip that I can power on with the use port here. Yeah. So first of all, I need to and the donenesses together here. Or not the donenesses, the nexts. The uses. How many ways can I be wrong? And then I need to grab myself one of these to put everything on. Now annoyingly, that means that I get to copy these left and rights again before dragging these all in here. And then rewiring every dang thing. How did I just power that off without doing anything else? That's fascinating. That's going to now be powered by that because I want to... That's annoying. This continues to be annoying.
Because they're grateful.
Boy, this just continues to be more and more annoying. These are like all the conditions that you could have within that, but honestly, let's go back to what we had with that wired up to those and get rid of that. So now we're back to the logic that we had before, but just a little bit more organized. So this steps me to the next thing, but also doesn't really respect the explicit like next signaling that I wanted to do, because as soon as this power is on, it like correctly steps us to the next thing, but I wanted it to stay in the next state here until I pull this down. As it is, we get a single pulse, which is like okay. I'll roll with it for now. I feel like this is gonna cause me pain. For now, we're going to put a signal manipulator on here that turns this into a pulse, because otherwise I think I'm gonna get some really unpleasant results. So, leave that there for now. That'll be fine. That's my next signal. Now we're going to do the stuff that happens when you compare when they're both numbers. It's a little bit weird that should this be part of this same thing? Probably. Probably. Gotta hook these up instead. That's wrong. Clear those out. Hook these up instead. And now we've got room to do the others. So what we want to do, if they are both numbers, is move please, thanks. Both numbers. Now the logic that happens here is going to be a little bit different. So per my algorithm, if they are, there's this extra flag that I'm not checking yet, which I guess I should just make the variable for already. I was calling it PS list for pseudo list. Normally I might just scaffold this and come back to it later, but I'm really afraid that I'm going to forget to do it later. And I have the whole algorithm sketched out, so I might as well do this now. So if they're both numbers, then we need to do somewhat different logic here. We will just get rid of all that, it's irrelevant. We need to know both the left and right this time. And we need to compare them, where if, what are we gonna do? We need like a result node out here as well. This is like a whole program result, because when you're comparing two numbers, if one is less than the other or one is greater than the other, then like we just report, we're done, we're out. If this is the case, then we wouldn't send either of these signals. But I just realized something. Per my algorithm, I was gonna have this stuff really needs to not live here. Somehow it needs to live outside, and I'm not sure what that'll look like. Think about that in a bit. But in the meantime, we'll just delete all those. That's kind of not relevant anymore. And what we'll do is we will compare if we're going to do it straightforwardly here. If A is greater than B, then we're going to return one value. I'm going to actually do it less, because less is going to be sort of our primary case. If it's greater, on the other hand, then we're going to do something else. This I can steal a little bit. I can just sort of steal the value sliders from this one. Less would be a result of 1, greater would be a result of 2, because I declare that 0 means they are the same, 1 means that A was less than B, 2 means that B was less than A. Those will be the values that I use throughout this whole program. So that is basically as simple as that, except it's not, because we needed to check this PS compared flag if they were both numbers. So that's part of it. Part of it is done. However, there's kind of a whole other side to this, which is I need to get the value of PS compared, pseudo list compared. And if this occurs, then we wouldn't return any of that. We would basically just return 2 right away, actually. So I guess what I can do is just that. I feel like that's confusing. 2 is the like you fail case. If this is set, we wouldn't want to do any of this. So I think we would want to grab a NOT gate. And power that, like run that into both of these, we'll say. That should yield the desired results. But also, if we do It's a little bit of a funky outcome here, which is that, well, I think I can make it work. We have to actually modify PS compared in this situation as well. So we would set that to 1, or to switch on, but only conditionally. Only if PS list was also true. Which I guess means I could just do that. I mean, it's a little bit strange. Probably makes more sense to phrase it this way. If PS list is true, then also PS compared. But also this should only happen in this situation as well. I said this was gonna be funky, and it is. Yeah. Okay. Let's see, I need to hook up the left and right as usual. The result here needs to be another node that we sort of borrow for the remainder of the output. I'm sorry, where are these coming from? Oh, weird. Very weird. Result will pipe in there, and if that's the case, then we don't want to do any stepping to the next. Things are just done, but we will just sort of keep an eye on that for now. As long as, yeah, that's got sufficient range, we'll be able to tell. So. Right now, this case is running. They are both equal, so the result remains 0. So we do want to step to the next one, but this is where I need to figure out how I'm doing this step, because I had this common behavior where I want to only step the how do I do this? I think I can actually make it fairly simple. If I'm unconditionally stepping, relatively unconditionally, there is a condition, but I'll get to that. What I basically want to do is not just do these switches, but I want to step whichever one is deeper or both. And what that means, quite simply, I think, is if I get the value of left depth and right depth, then the logic for stepping a particular one of those is if left depth is greater than or equal to right depth, step. And likewise, if right depth is greater than or equal to left depth, step. So, a little bit funky, but the result should be that if they're equal, both will be true. If left was greater than right, then this condition would be false and it wouldn't step. So I think that basically works. And I can shrink this whole thing a little bit. So if I'm to start this whole thing over, we step to that, and we step to that, and then we find 1 because they are properly sorted, 3 versus 5, and at that point, we're done. Yay, congrats. That just kind of worked really well, actually. As for like stopping when that's done, I'm not gonna bother with that at the moment. Let's set up, well, let's save this because we might as well. But let's set up the next part of, I need to have like multiple pairs of these and then one sort of like meta iterator that actually steps us from one pair to the next. What that means is basically, I think, I would duplicate this down. Let's see. First, I gotta make a new microchip to hold all these. Put them both on here, but then copy out their nodes. Because the nodes are the same. And in each case, that wires into and out of all the same stuff. But it can obviously be a lot more shrunk down. I want to make sure that I get everything wired correctly. So left count wires to there. Right count wires, no. Yeah, right count wires to there. This is left symbol, which wires to there, and also to here. It's true, there were 2 wires coming off that. Likewise, right symbol is going to go to there. And to there. And then I can wire each of these up in turn to the corresponding correct things on here. And this should leave me with identical behavior, and it seems that it does. So that's nice. On the other side, on the inputs, we just need these things. And delete those. And just like that. Simple as that. We've proxied it all over. Great victory. We're not quite done. We need to add the selector that steps us through all of the available programs in general. Which means that I need a pair index as well. And that one pulls in right here. And I guess we also, just to round out my painful collection here, need a num pairs. Which would come out of here. So that's lovely. And that now constitutes this whole mess. And I guess this means that I need one more big frickin' iterator. Which I can more easily just throw a switch on. What is this weirdo Disney stuff? Okay, beautiful. This macro level stepping sucks, but you're now looking at this whole program, which the problem is that it already somehow, oh, it's because that was on. That's my issue. Okay. It already tracked the depth. We're gonna ignore the fact that use isn't being used correctly there. And we're going to proceed with this one because we are currently looking at the second program, but I actually need to set this up to be the correct program at all. So we have open, open, one, close, open, 2, 3, 4, close. So all of this is gonna have to scoot down to make room for that pile. And then this has to expand to power. It's already powered. That's not true. There we go, that seems right. Okay, there we go. This one, on the other hand, is going to be a little shorter. It is going to be open, open, 1, close, 4. And that's it. So that's what that one's doing. So if we now step through this, we see open, open, What? The depth didn't increase like it was supposed to. And I suppose there's a great reason for that, which is that that microchip is just staying powered. Also, that microchip was supposed to be powered, but you know, whatever. Yeah, so that one just stayed powered, which is like stupid. It really does feel like I should be doing that. I mean, there's a reason that I have the done ports for the next port on my iterator, which is that while you're stepping from one to the next, you actually want a frame where you're not doing this stuff. Okay, now it's working. That's nice. Okay, so we step down. Yeah, let me start over and clarify. So first step, we increase the depth to 1. Second step, increase the depth to 2. We compare them and see that they're equal. Then we decrease the depth to 1. Now, both increased to 2 and they should not have. That's interesting and the fault of this logical chain here, wherein my power stuff is all wrong because sad and bad again. Tell you what I can do, each of these should have the like true and false variance just spit right out because of it being important to set up this chain. Because then I can just have that power this. If I do the same thing here, I don't have to worry about like powering these extra nodes in some weird way. That can power that, and bam. So that should be better. That should be just a little bit clearer and nicer overall. So let's rewind the clock and step through this again. So increase depth to, it was at 1, now we increase to 2. Now they're the same. Now we decrease the depth to 1. Now we don't know what we're doing because what we have here is a mismatched open. We are in a new part of my algorithm, if mismatched open. If that is the case, we increment the depth only on 1 and we set this pseudo list thing. Now we might have a slight issue with when this runs. We might have to figure that out. But for now, what you're interested in is, here, let me actually, want to get this up just for reference, so we can just sort of peek up at what state of the program we're on at each point. So in the case of a mismatched open, then there's some action that we want to take on that. Should be powered on by this. I'm not going to hook that up just yet. And what's going to happen there, we need to, as I said, increase one depth or the other, which I guess is going to happen by virtue of, here, I'll copy across both of these variable modifiers just to make my life slightly easier. Both of them would increment by 1. I can just hard code the 1 there this time. And these are both in add mode, so that's good. Hello, Phil is the boss. Coding and making games in Dreams is normally a lot less complicated than what I'm doing, because I'm trying to do programming challenges designed for real programming languages. So my logic gets way worse than your average Dreams logic by a long shot. In any case, what I'm going to do here, if I see, well, whichever one I actually saw the open on, I have to basically increment that. So we're going to pull that in, and then we'll compare to see if this one is the open. Where open, an open bracket in my encoding is a -1. And if that's the case, we'll increment the left one. These can't both be true because of prior conditions, so this is basically all there is. Is my controller drifting? No, not really. Apparently I'm drifting. The other thing is I need a variable modifier to set the PS list flag to 1. We have achieved pseudo list status. So this needs left and right to be passed in again, per usual. This will not return a result, but hopefully what we would see now is for, see up here, what we want to see is open, open, close, but then when we get to this 4 here, when we're at the 4 here, and the -1 here, we want to see this one continue to step a little bit. So we already kind of know, well, what we already know actually is that we messed up because I didn't wire this into the power like I was sure I figures. I'm looking at these things here. 2, same, 1, and now it did work. 2, one of them went to a deeper depth. Only that one did. And furthermore, we have set the PS list flag. Step to the next, and we get 2. These lists, that's not right. No, this is actually a bug in me ol' algorithm. So I think what happened, I think I saw it go from 1 to 2 because we like stayed on in this state, which is really unpleasant. Let's see. 2, compare back to 1, step like that, and then, yeah, it went 1, 2. So it's technically sort of working. That might actually be working well enough, because as soon as we get a result out there, program's over. No more happening. So, what we should probably do, shrank that down, make this, here we'll have a variable for result. Result 5. We will set that variable when something comes out here. And then if there is a result, no power, everything off, program done. So only if we have no result do we want to kind of run the rest of this logic. Hello, Vizian. I am in fact attempting to do code in dreams. So let's see. The problem here, the advent of code problem for day 13, I'm a couple days behind, but whatever, is to take lists like we have on the left here and check to see if they are sorted correctly relative to each other. The way that it works, like for this top example, 11311 versus 11511, they are sorted in the correct order because 3 is less than 5. They need to be in that sort of ascending order. For this one, they are also correct. It's a little bit more subtle, but it's because when you compare the list 2, 3, 4 against the number 4, you treat 4 as sort of a list on its own, like a list containing just 4, and then, okay, 2 is less than 4, so correct order. Then this 9 versus 876 is in the wrong order. So the lists are inputted horribly. This is how the lists are inputted. Because they need to be longer than any fat wire can do, and I need to be able to step through them. Because I need to sort of be iterating one at a time. So what I have is, this setup where I have a selector that steps through each of the selector ports, powers on one of these sliders, which are all wired together into the same output. So as the selector goes, I'm powering on one thing at a time. I originally was doing a bypass mode selector, but that has really annoying issues because right when the program starts, it like ticks to the final entry of the selector if the value is non-zero, because it's like, activate that one. And I'm like, no, don't. I don't want to do that. I don't want you actually messing with which one is active when I'm in bypass mode. In fact, I really kind of wish that that's just not how it worked at all in Dreams, but here we are. Anyway, I'm currently stepping through this list, so this example right here. And what I'm expecting is for the whole thing to halt with this set to 1. And we will see if that is what I get. Algorithm do good. Algorithm no halt at all. That's exciting. Oh. I need to actually, the problem is that the variable modifier was always powered and it was in the mode where it needs to, it'll only set when it gains power. So try again. Hey, it did work. We got a 1. Yes. This is not the most visually engaging solution I've done, but this is among the more serious logical solutions I've done. Since I hit that breakthrough, or since I hit that point, I can go show off some other solutions that I've done this month, since there's a new challenge every day. This one, you're supposed to see which trees are like obscured by other trees. So I have this guy just run around with a laser scanner all four sides to see which trees are actually visible. The lasers themselves are some sleight of hand. There's actually, I mean, it's called the laser sensor or something, isn't it, in Dreams? There are laser sensors on the trees themselves casting out that do that. Can reduce a matrix to RREF? What is RREF? This one, you imagine there's a rope between the two elves and the front one is pulling the back one around. So you can see that like the back one only moves when the front one gets far enough away, and you're supposed to count how many spaces the back one goes to if the front one follows a particular path. The answer is 13. This one was really not visually engaging at all, and well, this one was fun. People enjoyed this. This was like, you have a sequence of like crate moves to do, and then you're supposed to like figure out which crates are on the tops of all the stacks when all the movements are done. So I actually built the system to do that. So it's been really fun to try and do these like real programming problems in something that's really not designed for them. The most computationally terrifying one is this, which you're supposed to find the length of the shortest path up this mountain, which I do with a recursive flood fill achieved by having elves clone themselves with destination coordinates. I had to make them ascend to heaven and erase themselves because otherwise you hit the thermo limit, and Dreams hates you. So... But yeah, the early part of it is just freaking wild. Also, one of them has a bug, like he spawns wrong and decides that his home coordinates are 0, 0, and so he runs back there, and so there's a spurious 5. But it doesn't affect the end result, so I call it good. Also, they get stuck in this like sliding state, and then I have to do like a cheap extra jump just to get them out of that state. There's like a hacky timer on there. This problem that I'm currently doing is clearly structured recursively. Oops. But I found a way to do it that doesn't involve recursion, and I'm sticking with it because I did not want to have to deal with all of that like recursion in Dreams is extremely weird. You have to put an emitter on an object and then point it at the object itself by... Well, you can point it at itself, but then when you collapse it, it's like everything's gone, right? But if you turn on preview and if you turn off preview and visibility, then you can still find the object there, and then you can hook up another emitter to the same thing so that you can emit the first version, and from there that one can be used to emit the first thing, and then they can subsequently spawn themselves. But then you have the problem that like when it spawns a copy, you have a like perfect clone of the parent, which means how do you tell if you're the parent or the copy? How do you get it to have different state? But you can do this with variable modifiers that are always powered on, because when you clone it, if you had numbers coming into the variable modifiers that were different from the thing at the start of the parent's lifetime, then those wires are just sort of sitting there with a value, but the variable's not being set because the variable modifiers only go when they gain power. So then when the new one spawns, those variable modifiers on their first frame have power and the old number values coming in, and so they can be set to something new. And then this is how you can distinguish yourself. It's utterly baffling, and I did not want to have to do it today. I ran into so many weird issues with it, you know, I just don't want to unless I have to, but sometimes you have to. So that one seemed to work great. let's I just have to set up a little bit more. I need to be able to like tick through to the program of my choosing here in order to go through all my test cases. So let's collapse this and make another program, the 9 versus H76 case. So that needs that and that to be wired in. We need the third selector port here to power that. And then we need to output all 4 of these, and then we can dive in and modify. Iteration is just like stepping through a list. Like you have a bunch of just, you know, so you're at like index 0, then 1, then 2, then 3, then 4, and you're just, you know, iterating through each of them. Recursion is where you have a function call itself. So the way that they intend for this problem to be done, for example, is that you would sort of have a function that compares 2 values, and the value can be either a list or a number. And then there's rules within that. And so then you would compare the list, like the full outer list against the full outer list. But then that function would call itself with just the list containing 1 in each case. And then that would recursively call the same function again, but just with 1 and 1. So you have a function calling itself and then going back up a level and then going again. And so you have this like stack of things with data going up and down, and like it's very powerful and very like conceptually elegant. It would be much easier to solve this problem that way, using recursion in a programming language that supports it. But it's so much harder to do in Dreams because of having to spawn objects in the world and make sure they can communicate. That, like, no thanks, not unless I have to. So let's see here. This is going to be pretty small. We're just going to have open, which is -1, and 9, then close, which is -2. And that is the entirety of that opening list. Then this down here is going to be a little longer. We have open, open, and then 8, 7, 6, and then we're gonna have 2 closes. Dreams can do recursion through feedback loops, plugging the output of a system back into itself. The thing is that's not recursion, because recursion implies that you actually have sort of multiple instances of a function happening all at the same time. You sort of have a stack of functions in progress. So like the way that they explain it here, you know, if you wanted to compare one, you know, this list against this list, then you start by comparing just this list against this list, and then you start by comparing this number against this number, but then you actually produce a result, and so then you're done. But then you sort of hop back up a level, each list continues on to the next value, so then you're comparing 2, 3, 4 versus 4. Dreams can't do that. Anytime that you would have to do something like that in Dreams, you have to use an emitter, because it means putting new code in the world, right? You have to spawn a new object that contains logic, and all these objects have to be able to communicate with each other in some way, which, I mean, it's doable, right? You've got wireless transmitters and all that, so it's certainly possible. And in some cases, you don't even need the wireless transmitters because you can emit things with wires, but it's it's still kind of wild. So I think it's literally impossible to do without an emitter. I just don't think it can be done. because it fundamentally means, I mean, at the heart of it, you can imagine that you would need new variables, new data, like, you know, whatever the logic is that you're wanting to do, you need to have a separate copy of it so that any selectors would have their own state, any timers would have their own state, any, like, whatever it is, right? It needs to be distinct from its parents. So it gets really wild, and we're just not going to. If I can avoid it, I will avoid it. This is wrong. This is supposed to be -2. Open, open, 876, close, close. We'll leave that open. That is our current program. We are now going to step forward to this one and then activate our whole world here. Okay. Okay, that's true. That's true. You could do a fixed amount of recursion by having copies strung together. And honestly, that's not a bad solution. In my opinion, it would probably make a lot of things easier. If you want true unbounded recursion, then yeah, you need to do emitters. But you're absolutely right. You could just have multiple copies of the same thing that are all wired together so that, you know, you can just use only the ones that you have to. And actually, I should probably keep that in mind as a valid approach if I'm like, I want to allow recursion, but only up to 5 or 10 levels deep, right? Because with something like that, I could feasibly set it up where, like, you know, because you can use the sub scene, sub element sort of thing where you can select something, make it its own element, go edit it, save it, come back to the main scene and use the update mode thing. Like, you could feasibly keep everything in sync that way. So you make a good point. Let's see. We expect this to fail almost immediately. And not fail per se, but well, it did actually hard fail in exactly the way I didn't want it to, so that's nice. Hold on. Did I get this right? -1, 9, -2, -1, -1. Oh. I think there's yet another logical case that I didn't implement in here, which is indeed, no, we're talking about mismatched open. Okay. We're about to figure out what's happening. So again, let's set it up. Tick through to that, enable this. So now what we have here, these are the depths that where the way that I've set it up is that, like, open bracket, like to start a list, means that we increase our depth by 1 to just track, like, how many lists deep we are. So the open bracket on both the bracket 9 and the bracket 8 means that we step down by 1. So that much is fine. Then we step to the next thing. But this is not... Or no, this is actually fine. This is actually correct so far. Where we had an open on one but not the other. That means that we want to step the second one down to a deeper depth. However, I think that maybe what didn't work is this didn't work. Yeah, I was afraid of that. that there would be something weird there where like these things are going to sort of really these are dependent on these, and so that's not ideal. What I could do is, if this is really just getting the values of left depth and right depth, then here's what I can do. We can have each of these sort of cases output that depth info themselves. Oh, by the way, Vizium, you said that it would be horribly inefficient. I don't think it would really be that inefficient. Like, it depends how many copies of the logic you have, I suppose. Oh, that is some gnarly controller drift. It depends how many instances of the logic you have. But, you know, something on the order of 10 to 20 would honestly be like exactly as much logic as you would expect to find from just like spawning a bunch of little effects in the world. Not really a lot of logic, and it would probably be more than sufficient for most Dream's logic problems. So I think it wouldn't actually be too bad to sort of manually unroll your recursion to a certain depth. I mean, it feels terrible, kind of, but not really the end of the world. So that's going to fire on, let's see. Oh, this is still kind of unpleasant, actually. But, oh yeah, no, this isn't actually going to be an improvement. For stuff that changes the depth, let's start, honestly, by moving this out here, because I don't think it's really even conceptually part of this. It's kind of just like, oh yeah. Call me a dummy. Because I think I have this whole iterator thing for a reason. I have these iterator helpers that are basically wrappers around counters, but that have a more explicit way of stepping through them where you feed in next, but then you have two outputs here, use and next. They're mutually exclusive. It's like use, then next, then use, then next, then use, then next, because if you don't, like I found early on in this challenge that you really, like when you're iterating through stuff, you don't want to have using a value and changing the counter to the next value to happen on the same frame ever, because things freak out, things get weird. You really want to explicitly be like, I'm using the current value, now I'm not using the current value and stepping to the next value. And then I'm using the current value, and then I'm stepping to the next value. And you want to like have those be completely mutually exclusive. So that's why I have this thing here. This logic here is fundamentally part of stepping to the next thing, and should only then happen when whatever. well, this might work now, just having it out there. Not 100% sure, but we'll find out. So let's kind of reset this whole world again. Step to that program, enable everything, and start working through. So starting with, we're at that depth, and then we step to there, and then hey, that actually did work that time. We got a 2. That means that these lists were sorted in the wrong order and everything halts. Yes. Okay. Save that. Progress, progress. So let's input the next one. 4, 4, 4, 4, 4, 4, 4, 4, etc., etc. This one's going to be kind of odd. Also, open, open, 4, 4, close, 4, 4, 4, open, or close. Whatever. There's 9 things. That still fits in a single selector, and I don't have to suffer. Conveniently, I can just avoid ever touching that bottom one, which is a little bit too big for my liking. It's more than 10 things long, which means the selector setup has to like be a lot worse. I have to have, because selectors can only go up to 10 ports. So then I have to set up like cascaded selectors that like, oh my goodness, it's annoying. It's again doable, but I just absolutely do not want to do it unless I have to. Why? Controller drift. Just stop drifting. Please. Thanks. So, let's set up yet another here. Hook up all the wires. So many wires. And then go dive into what this program actually is. So, open, open, 4, 4, close, 4, 4, close. 8 things. You want to make a recursion tool. How to get the emitted wires to link up properly. Yeah, I'm not sure. I feel like your only hope, I think, would be to use an emitter, use emit with wires, and then use bake emitted. But even then, I'm not sure how it would work, because the problem is you can't, as far as I can tell, this is maybe narrow-minded, but well, it needs to run while in a dream. I mean, I guess if put aside the bake emitted, if you can emit it with the right wires, then you did it. The issue that I ran into is that emit with wires would normally work, right? Because you have the sort of spawning, the spawner object and the spawned object, and you can have wires from one to the other. And when it spawns, it preserves those wires. But the problem is, if you want to clone yourself, then you need wires to yourself, but that like go between objects when you clone and aren't still pointing to yourself after you clone. Which, like, how would you do that? What you could do if you want just pure logic is you emit them in very specific places and use wireless transmitters in very specific places. And in fact, that might be more reliable across the board. Right? You just say like recursion starts here, and then you can just emit, you start at 0, 0, right? And then you emit at 0, 1, and then 0, 2, and 0, 3. And each one has a wireless receiver It has a wireless transmitter on it for any communication that needs to happen, maybe many, and a wireless receiver that is like at one down, so that it would receive from the next thing in the stack, right? Because then you could dynamically have that kind of flow. Spaces? I'm not sure what you mean by spaces. Probably a Dreams feature I'm not aware of. I'm not really up to date on all the cool Dreams stuff. Oh, emitting the functions at different points in space, yeah. I mean, I don't have any better ideas. That is my best idea. Let's see, am I doing this right up there? I am doing that right up there. Then here I need 4, 4, 4, and another close. Please. Okay, those are good. A bunch of these are not hooked up. In fact, like most of these are not. So, time to do that. Huge thanks to whoever it was who told me that I can hold down L1 while placing wires to like continue placing wires. I did so many days of this challenge, like back and forth, back and forth, back and forth. Very tedious, very glad I don't have to do that anymore. Okay, so there we have our next one. And this is actually going to, actually it should be fine, because the case this is gonna hit that I haven't coded yet, which I guess I just should code now, is mismatched close. So it's that time of year, huh? What are you studying? What's the final? Signals and systems. Are you like an electrical engineer? Let's see. Actually, don't want these. So these I have to change to -2. That corresponds to the if mismatched close reduce. I need that for reduced depth on closed. Ah, for crying out loud. I did need those. -1 on this. However, we're only going to do that if the depths are, this is going to be a little bit funky. Funkiness. I need to actually get the value of right and left depth. And if they're equal, we're going to do something different. I mean, it definitely sort of sounds like an electrical engineering thing to me, but it's funny. It just struck me as like funny how similar it is to what I'm doing here. I mean, in fact, a lot of the stuff I do in Dreams does remind me of like electrical signals and stuff, right? I mean, it's all wires. Why does my controller want to drift so bad tonight? Like, stop it. I can reset it, like, temporarily, but... Okay, so if they are the same depth, then we want to actually produce a result. So that would be, I should swipe from this by outputting one of these depending. Let's see, this is gonna be like what? So if they're equal, that's gonna be whatever. However, if they're not equal, then I need to actually pick one of these depending on which one is greater. So if the left one, we want the left one to run out first. That's the condition that the problem specifies for us. Yeah. Which I guess would mean... Oh, no. If they are the same depth, then we would want to go based on which one is being closed. Closing the left one means that it was shorter, and therefore they're in the right order. Closing the right one means that it was shorter, and therefore they're in the wrong order. That's if they're equal. We would power on this output. If, however, they weren't equal, then we would power on these variable modifiers and clear flags. So where I think I'll probably want to put all of those together on a microchip just to make sure that it's easy to set the power accordingly. Okay, then power for this powers that. Left and right feed in here. Result feeds out here. And with that, we might be ready to give this a try. So let's step through to this, activate the whole deal, and start stepping. So what we expect to see is that we go to depth 1, depth 2, couple iterations there where we compare the 4s, then back down to depth 1, couple iterations where we compare the 4s and then we output I freaking knew it. I freaking knew it. Copy pasting math nodes keeps just messing me up in weird ways. Because they end up like, oh, I'm gonna modulate this value. It's like, no, don't do that. Anyway, that outputted a 1 like we wanted it to. So great, victory. With that, I mean, honestly, my whole program might be working. But we gotta test all the remaining cases. So if I close this down and we'll just keep on expanding, it's time to do that example with all the 7s. Painful assembly of all the wires. Tack that on and start setting this. So it's just open and then 7 and then 7 and then 7 and then 7 and then close. And down here, it is open, 7, 7, 7, close. Okay, that seems good. Give our program a go again, where we step to this program, activate stuff. Ah, phooey, this was already powered on. Reset. All right, now we go up to 1 and then do a bunch of comparisons and then power off with a 2 because the write list was shorter. Yes! Okay. Empty list versus 3 is coming up next. This one is just mercifully short. -1, -2. And then -1, 3, -2. I guess it's theoretically a problem that that was wrong, but in practice it's not actually a problem. That goes for like all of these. Where I've got like 2 slack ports on there, 4 slack ports on here. But like in practice it really doesn't matter because iteration stops anyway, so probably won't mess with that. Thank you for hanging out, Visium. Hope your finals go well. Hope you get good sleep. Do try to get good sleep. Yeah. Oh, that's my problem. Power. Okay, so reset the world. step to that program, activate things in only 2 clicks. We are done with a 1, and that is in fact correct. So that's good. One more to do. I mean, I guess if I wanted to set up that whole thing, I could, but like I don't, so you know how it is. Let's hook those up. These up. Hook up another power. And then let's jump in and, oh no. Well, it's fine, it's not actually that different. We need 6 of these. That'll be open, 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 close, close, close. Now I do need to wire up all this power, which is a little bit painful. But not the end of the world. Same drill down here. Where this one is only 4 things, so only 1 more thing to hook up this way. And that is open, open, close, close. Let's set this up. Activate this, and then depth 1 to insta fail with 2. Yes, it's working. My whole state machine is working. This is actually some of the nicest logic I've made during this whole challenge. We're coming up on the 3-hour mark, which is my sort of benchmark for these problems usually. So to have the core logic working at this stage is very good. I guess I really should implement that one really crappy long example. It's so irrelevant because it's so obvious to me that it'll work. But like, if I have to, I have to. The problem, as I said, is that I have to do these like cascading selectors, which is just the worst. So let's make some room for this. This is going to suck big time. I need to copy 4 of these because there's going to be 10 on this guy. Excuse me, 10 on, excuse me. Please copy. Thank you. Never will I ever understand how Dreams gets itself into these states. Okay, so this is going to be really annoying. It's going to be open and then 1, and then open and then 2, and then open and then 3, and then open and then 4, and then open and then 5, and now we need more data. We need more things to be wired up. Which I love, it's great, it's so good. let's start by wiring up all these. So now the issue is we need to have, as I said, multiple layers of selectors here. And that means that we get to do a little bit of math tricks with this index, where we need to divide by 10 and round down. In order to get which of the like 2 selectors we're going to use. Because there are going to be 2 selectors. And then within that, we need the remainder of division by 10 to tell us which port within each selector to use. Typical modulus and division stuff, but a pain to have to do here. I'm going to lay this out horizontally because I hate myself. Let's see, first I need another selector here to serve as the selector. That's what that goes into. I'll pull this well off to the side so as to make room for, let's see, I got up to 5, so then it's 6, 7, close, 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 8, 9, close. Wow, 9 more? Really? Why do you have to be so long? Okay. Oh yeah, and for left count, now it's gotta like, I've just gotta hard code this to 19 because otherwise things are too terrible. Thankfully, the rest of these are mostly not completely terrible. I can set this up. So we ended at 5. So then this should be 6, 7. Then we have close. Close, close, close. 8, 9, close. Sit down. So that's that whole mess. Now time to replicate it down here. In fact, I am going to just replicate it down here very, very directly. Is this really called left index? Did I call these both left index? Well, it doesn't matter. You know, I just have a major naming mistake in every single instance of all these things, but it's fine. Why is it so weird about selecting value sliders? Just don't do good. Other things do good. You know, why this no do good? All right, a lot of wires to hook up. U down, same as ever. And all of this should be the same. Open 1, open 2, open 3, open 4, open 5, 6, 0, close, 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 8, 9, close. Thankfully, all the power is wired up. The thing that needs to be wired now is just all of the actual values. Not too bad. Now here's hoping it works. That's the real terrifying part. So here we are. We find ourselves upon this 1. What we're expecting to see is for this depth to climb up a lot. So we did a compare, then depth up, then a compare, then depth up, then a compare, then depth up, then a compare, then depth up. And now we should see compare 5. This is both numbers. 6. And we're done. 7. This came out 2 because they were sorted in the wrong order. It works! It works! This all worked! All the logic is good. Ah, thank goodness. All right. That is super exciting. Now, I have the less enviable task of making this look pretty. Is that less enviable? Who can say? Who can say? I am really happy, can I just say, that my iterative solution worked. Like, that feels really good. That's fantastic because I managed to turn an obviously recursive problem into a totally iterative problem. And I just feel great about that. I'm super pleased that that worked. My pseudocode worked. I didn't miss any cases. That's awesome. I ended up with such a more reliable, simple solution as a result. So glad that that panned out. Now, as for actually making this more presentable, how does one compare going through list by list like this? This seems like one where I might just have two elves with thought bubbles sitting across from each other, thinking through symbols and something like that, you know? All right, 1 second. This freaking mic, it's just amazing. Terribly balanced. I should go find wherever I bought this thing from and give it a terrible review. Don't buy the Blue Yeti mic arm. Blue Yeti itself is okay. Don't buy their boom arm. So, creative juices here. I can't really think of good ways to like present these two lists. You know, like I struggle to think of any visual interpretation of this problem. They're just lists. You're just comparing lists to see if they're sorted. So, with that in mind, I think that this is basically going to be just like two elves sitting around the campfire comparing lists. I can at least make it look kind of nice. I should really save this. I keep like modifying the emissiveness of all of these things together. Just to give it a better overall glow. Make sure you can't be possessed. This keeps causing problems. Then, let's see. What does the Dreamiverse have for Thought Bubble? Oh wow, for the first time, the Dreamiverse fails me. Here, I should hide all that stuff now. We're just making the problem pretty. So this is gonna be like what? Yeah, I don't know. I'm not gonna do anything that requires me to sculpt, I'll tell you that much. What does this do? Oh. Okay, whatever. Doesn't matter. Like I said, I've never actually used Dreams for its intended purpose. I don't know what most of these things do. Text Gadget has options that could work for Thought Bubble. Oh, okay. Let me look for those. Are you talking about the dialogue text displayer or the text displayer? Oh, that's right. Okay, that's right. Yes, thank you. I totally forgot. Oh, weird. Whoa. That is, in fact, some wonk. Controller drifting again. Okay, that'll work nicely. Because I can still, I presume, put this in world in like exactly the same way. But let me start by putting... Let's see. Basically, I want to like scope in here. Just so that like I don't have to worry about how they're moving around. Let's see here. In scene, please. And what would they be? What would he be saying? Well, in my case, it would be something like open square bracket, and I'm going to need like multiple duplicate text displayers to handle everything that I'm doing here. But so be it. I suppose that means that I'm going to want to not do the auto width thing. And instead just do something like this. I did succeed tonight. Thank you for asking. And in only 3 hours. It's a very like technical problem that I struggle to think of a fun way to visualize, so it's just gonna be a couple elves sitting around the campfire saying symbols to each other. That's all it's gonna be. I can still make it look at least a little fun, but it's basically about taking input data in the form of like nested lists and then sort of recursively comparing them to see if they are sorted correctly. It's thrilling. Oh, let's see. I will organize it like this, where this one like has it sort of on top and the other one will have it sort of below. Yeah, it's technical enough to be really quite boring. How do you convince your controller to stop drifting for real? Gyro sad tonight. That's all it is. You know, it's just a case of the old sad gyro. Let's see here. I want to like roughly set up the other. That's not what I meant to do. The other ILF. Wait. There's non-gyro controls that still use the gamepad for create mode? You can just like, you have to like manually fly the cursor like X, Y, and then flip to Z, like, surely not. Surely not. That would be, no, I'm good, thanks. That is terrible. Just terrible. Just awful. Just terrible, awful people, I guess. That is insane. Who would subject themselves to that? You know, I feel the same about, I mean, I actually feel that way about pretty much all gyro controls. They're like strictly better whenever they're available, and anybody who doesn't use them is crazy, and I just don't get it. Like, if you're playing Breath of the Wild and you want to aim arrows around, you know, you aim your bow, but you want to not use the gyro, what is wrong with you? If you're playing Splatoon and you don't want to use the gyro, what is wrong with you? What are you doing? Why are you just making your life harder? All because you're like, hey, it's like the Wii. No, it's not like the Wii. The Wii didn't have gyro at all. It just had accelerometer, which is why Wii Sports Golf, you're just always like, you know, putting, and then you like try to swing this way, and you just like, like swing awkwardly backwards because you're trying to just get these like acceleration motions with an accelerometer, and you don't have gyro. It's a miracle that Wii Sports works at all without a gyro. I don't understand it. But like, that's what people are opposed to. People who think that gyro is bad are just wrong. They're just wrong. There's my little soapbox rant. I will just never understand that. Okay. So, I'm realizing now that I've made a terrible mistake and I should have put microchips. But it's fine. It's not that terrible a mistake. It's just a moderately terrible mistake. Get yourself on the microchip. There we go. The reason that I need to do that is because I need to duplicate said text displayer for the other bracket, and then I need to very painfully recreate the text displayer as a number displayer to show the numbers. Which, like, fine, whatever, you know? It's like, whatever. Also, if I select both of these, no. I guess I should maybe style the bubbles exactly how I want first, come to think of it. Like, let's set the rest of the scene. Not that there's much other scene to set for what I'm doing here. I think that the only main other thing would be that I need some way of kind of displaying the output. I guess I need to get the camera in here too. We'll be sort of at the campfire with our friendly elves. How at the campfire do we want to be, though? Not that at the campfire. I also am going to need a way of displaying sort of a like success or failure. And I guess I want to do that. Hold on, I need to look up the like dreams icon reference. Cause I remember that you could do this. They've got their whole long page. I just want like a check mark. Check mark? Please. Oh no. Oh dear. Hold on. Where on earth do they keep this? And let's see. Make a third-person shooter. RE4 style. Ooh. UI tick. Thank you. And so, okay, hold on. I thought that the tap Giles. I literally just did a search that found it, and now. Oh. Cool. It's a little hard to see. Is there a search box at the top? No. No. I was doing it. Except that I can't tell which thing it's selected most of the time. Checkpoint. What is currently selected? No. It is still apparently just called tick. But whatever. UI tick. Tick circle is actually pretty good. Yeah, well, fair enough. They're allowed to be from the UK. I will allow it. And let's see. So UI cross circled and UI tick circled are what I want to use here. Uh. Let me bring the program over here. I will be needing that. How can I select so many things and yet fail to select the things? This is easily the most clean and tidy Advent of Dreams layout I've had. Like, all the code is pretty well organized in here, where we've got the logic for different things and the actions that we perform on those different things. Feels good. I'm going to drop in a text displayer for the like success and the failure case. So that is going to be, so do I have to type the angle bracket on it? UI tick circled. Hey, look at that. I do like the shadow, to be honest. And then UI cross circled. More typing. Tick and cross. So those can be powered on depending on the result that we have. But I have to figure out how to sequence everything anyway. So well, I guess I should set up my number displayers too. Honestly, this is like the whole text and number displayer thing is one of the things I really like the least about Dreams. I really don't like having them be separate. I really don't like having zero ability to manipulate strings, like, and it doesn't feel like it would compromise it that much to like have a string type fat wire, you know? Like, you could have that, and then you wouldn't need two different widgets for these things that are almost entirely the same. I mean, I know that there's a little bit of stuff related to number formatting, but like, text gadgets were a late addition in development, like in general? What would you do otherwise? I don't understand. I need these. I need it. I mean, these are like literally the same, right? Like, why is this one different? Oh, they don't have the big gadget version, but other than that. Artsy and simplistic. I mean, like, I mean, sure, but I don't know. In the end, it's just a decision I can't really get behind. I mean, like, strings, man. I mean, I'm sympathetic to, like, I guess I don't know how you would do, like, variable, like, any length of list. I recognize that that's the kind of thing that is difficult to express well in your logic system. But strings that are allowed to be a little bit more opaque, like, come on, man, that'd be kind of nice, you know? It's not a list of values, it's a string. And you could hack around it, I guess. Like, I don't know. Maybe lists could work too. But lists imply a lot more than strings, I feel like. You know, because then you would need all sorts of stuff related to like text encoding. Whereas if you just had a string type and you could have like string, you know, like how you have the value slider to just put in a number, you could have like just a plain old string box. You know, type a string here, and then you can just pass the string around. And then you could pass that into text displayers, and text displayers and number displayers could be the same. But then you could get all the power back by having a number format. Not all the power, I guess, but you could have like a number format node that you could use to display a number in the text displayer. And like presumably it could magically do that if you wired a number into the text displayer. Like you could easily just hide some stuff around that. So then like the absolute most common case is people are still just typing strings. Oh, and then the one other thing that you could have is you could have like a get character thing, so that you could pass a string, a fat wire of type string, into this node along with a number, and you could extract a character from it. Well, I guess that goes back to this difficulty of like text encoding and like ASCII and non-ASCII and stuff. So fine, maybe you don't have that. I would settle for just having a string type and a number formatter node. Because honestly, literally all it has to do is this, right? It's like display as number or time with this many decimal places. That's it. That's the extent of the stuff. So, well, and this, fine. Showing milliseconds for the time. I feel like it would not compromise the system, add a bunch of complexity, cause sort of multiplicative complexity where it like now everything has to handle strings. You know, most things could still just be like, you know, the same way that other fat wires reduced to a single number were required. Like, same deal, right? Same as any one of the more complicated signal types that you have on fat wires. Anyway, I'll get off my soapbox and line up these. Oh wait, there's something else that I'm forgetting. What am I forgetting? Some property of the box. I think it was just that. Yeah. Oh, interesting. Those are completely depth sorted. They can't clip into each other. That's odd. It's fine though. Looks great. So there will be some slight misalignment, but not enough to worry about. Let's see, let's set up the same thing over here. I have been seeing a lot of the create mode updates lately. The audio spectral thing looks crazy. I have no use for it because I have no audio talent, but it looks crazy and like pretty cool. Also, you know, stuff like wide calculator was like a super, super welcome addition. So I'm a huge fan of the wide calculator. It's about time. All right, so with that all lined up, I should be able to now do some stuff where we pass in the left symbol. Or let me steal these two ports. Put one over here and one over here. And then we'll do a little bit of logic to choose which of these to display. I guess I should also hook it up or whatever. So what we want to do is if it equals, we're gonna have, I guess I'll probably lay these out a little differently. If it equals -1, then we'll display this. If it equals -2, we'll display this. And if it is greater than or equal to 0, then that. Now, is this going to do that jank again where it's showing multiple things even in like game mode? Yeah, what gives? What am I doing wrong lately that for some reason my text displayers and number displayers just display unconditionally and I can't hide them anymore? Like, what is going on? I've got preview and visibility on, and furthermore, I was in game mode, so it's not like that matters. But like, for crying out loud, when I like take this number displayer and power it off, it's not disappearing in the world. So like, how is that possible? What am I doing wrong? Or is it working? Am I just crazy? Maybe I'm crazy. Never mind. Maybe it's not happening now. I was having an issue yesterday with that, and I thought I was having it happen there, but it was probably just weirdness like this. So, whatever. Come on, man. So that should be sufficient for that. The one extra thing I guess I can do, I'll have to modify slightly what's happening up here. In that the numbers that I'm putting out to those, I'm going to be selectively showing and hiding these bubbles at different times. Let's save this before I get too far. So now what I need to do is kind of set up the whole thing. We're not going to use my weird clock thing. That's just been playing out badly for me lately. So what we're going to do, I think, is when this thing is in the use state, we need to start a ticking timer here. We'll start it at 1 second so it goes nice and slow. When the timer, so first of all, we reset the timer when we enter the use state on the thing, because that'll kind of start out ticking through the whole program. We will also power the timer on in general when that becomes true, and off when it becomes not true, which is important. When the timer is finished, I want to also reset it so that it just keeps on ticking. That's hopefully all there is to it. I'll wire that in place of this, and in fact, because it's a pulse, I can get rid of that signal manipulator. Okay, we're off to a great start here. Yeah, that's kind of just a debug kill switch, which was off, which explains why nothing was happening. Well, that just didn't reset at all. Now, because it's already powered, convert everything to a pulse. Lol, it will work. You will never have bugs from converting every signal in your program to a pulse. It just fixes things. Okay, so far so good though, actually. What happens when we actually finish one up though, we need to go into sort of a sequence where we display that final like check mark or no, and then move on to the next one, which I think that should be pretty easy to do. I'm gonna start with a variable modifier that gets the value of the result variable. And as soon as it becomes something, everything else will shut down and we can start our sort of next thing sequence, which I think is going to look like, first of all, wait a second. Just for just to display the last entry, and then when that finishes, we will go ahead and do another timer here that shows the yeah, that doesn't matter. We'll do another timer for showing or hiding this little indicator down here. So I think basically then we're going to want a selector, probably. This timer will then last for some period of time and then take us over to the next state. When we're in state A, we don't want to show anything. When we're in state B, that's when we want to actually show one or the other of those. So what that's going to look like, I think, is just we'll get the value of result. I guess I'll just put these two. We'll just power both of these like so. Oh, that's not quite right. Each of them needs an AND gate on them because we have to do a little bit of a comparison here. So if the result equals 1, then we're going to power that one. If the result equals 2, then we're going to power this one. That is going to be power to this. That is going to be power to this. Very sensible. Very sensible. I'm a dummy. Every time I use an AND gate, I should have used a microchip with power. I swear. Every single time, without fail. Doesn't matter the context. See how much cleaner that is? It's just always right. AND gates are never right. Power is always right. Anyway, when that timer is done, that's when we will actually do my wireless transmitter thing that says next pair, which I haven't set up yet. So, about time I did that. There we go. Well, that sort of almost worked. I think that several things aren't resetting. Because, yeah, it's like immediately somehow wrong. I guess let's see, next on here needs to tick to reset on there. It's still not working because the result variable wasn't cleared, which is not surprising. Let's clear that. We do actually have to set all the variables back to 0. So every one of these is going to be set. So left depth, right depth, and the 2 flags. Why do you insist on being spaced out wrong? I will never understand. All this is gonna have to go on a microchip anyway, so. So my worry about that stuff was not relevant. This is the big ol' reset. This is good. This is good. Gonna stop that because I know that there's a little bit more that I have to do anyway. I need to, so one of the actual problem things, where is it? Here it is. What are the indices of the pairs that are already in the right order? I need to actually have a variable that's tracking the sum of all of this stuff. Kind of weird. there's just a single number answer that they expect out of me, and I might as well get it. So, when we hit this state and display this thing, we want to modify that sum variable by adding the index of the curve. Well, only if this thing is equal to 1, I guess. Let's see. If this thing is equal to 1, which is what this is, then we want to also power on this variable modifier and add the index that we're currently on plus 1 because they counted as being 1 indexed for whatever reason. I guess because otherwise if the first one was valid, how would you know? That is index right there. Okay. And then I guess I probably just need like one more number displayer that displays the sum. That's, if I do that, I'm going to be sad because that's going to move the other text displayers that I have going. I kind of think maybe when it's all done, I'll show that final thing. For now, I'm going to just put this up here. This thing gets the usual bold white text, no box, no border, keep the shadow, put it in the world treatment that everything else has been doing so far. I will allow rotation. Do I still have stay upright on? I do. That's nice. Because what I want is a big fat number right here. Ish. Right like here. But like... but more like here, if that makes sense. That will be the eventual answer to the whole problem, because this is only going to be displayed when this whole thing is done. Let me speed up this timer. It is adding to that, so that's promising. I need to hide the text boxes in some cases, but $13, huzzah. We got the right answer. I just have to make it pretty, and that's it. Boy, that's some ugly wiring over there. I just realized. It just looks horrendous. Let's see here. I want to have a couple output nodes that I can refer to here. I'm not even gonna bother naming them because, like, who cares, right? It didn't work, did it? Anyway, the reason that I want this is because then I can power them on and off more easily. If I... Let's see, when do I want them on? I want them on when this whole thing is active. That's not quite right. I want them on... Actually, it can be right because I think that this will work. See, I'm first going to pass the power in there and there, but also this state will power them on. Let's see if that works. No, this is very awkward and also terrible. You know what? Big mistakes were made, just so many mistakes. We're just gonna pretend that I didn't make those mistakes. What I'm gonna do instead is have these things control power to those microchips. If this, there we go. Because then what I can do is, well, actually, they can both be off the same port. This is just hide thing, or really show thing, but hide thing, you know. We'll make it hide. We'll just throw a NOT gate on there. Where when we are in this state, then we'll hide them. Mild jank, where we get like one frame of some other thing showing, but it's fine. I think only in the done state is this going to be wrong now. Yeah. But we'll just pull that in here too. So now the whole thing should just run happily. Actually, let me just do the thing in game mode because... "13's the answer. You can see it right down in the message at the bottom. So, that's a pretty good. I mean, I guess that's it, right? Unless I want to sit here and make it prettier. And I don't, because it's 12:45 a.m. So, let's go ahead and save and publish this guy. Let's see. Release. And we'll add it to the old collection. I remain only 2 days behind. Haha. Yay. All right. That does it for the evening. Thank you all for hanging out and helping me debug things and just keeping me sane in general. Is anybody I know streaming? No. Well, that settles it. All right. Thanks all for hanging out. I will see you again tomorrow. Bye.